I'll be finding the derivative of cos x using first principle. So y is equals to cos x. Then to differentiate from first principle, is y plus change in y is equals to cos x plus change in x. Change in y is equals to cos x. We have to take this y to the other side. So x plus change in x minus y. So what is our y? Our y is cos x. So that means we are going to replace this y by cos x, since y is equal to cos x. So we have change in y is equal to cos x plus change in x minus cos x. Then we need to expand this cosine additional identity. So that means we are going to have cos x cos change in x minus sine x sine change in x minus cos x. So what we are going to do is that we look at this, we consider that there are some that look alike, that is the like times. We have cos x here, we also have cos x here. Though we have cos change in x here, we don't have cos change in x in any other place. We have sin x here, we don't have a, so the like times we have there is cos x and cos x. So we bring them together. So what we're going to have is cos x cos change in x minus cos x, then minus this minus sine x sine change in x. Then we factorize, and this one is still our change in y. So if we factorize, we have cos x into the open bracket, so we still have cos change in x here minus 1 minus sine x sine change in x. So what we are going to do now is that we divide both sides by the change in x, since we are looking for the y dx. So change in y and change in x, we divide both sides. Whatever we do in the left hand side, we must do it in the right hand side. Cos x into cos change in x minus 1 minus sine x sine change in x divided by change in x. So what we have to do now is that we have to find the limits of both sides, since we are looking for the y dx is equals to limit of change in y over change in x as change in x approaches 0, which will be limit of cos x into cos change in x minus 1 minus limit of sine x sine change in x divided by change in x as change in x delta x approaches 0. Therefore, there is a need for us to break this one into different sections. So the y dx is equals to limit of cos x into cos change in x minus 1 over change in x minus limit of sine x, sine change in x over change in x. This one as delta x tends to 0. Delta x tends to 0. So what we have is that by known and established limits, by known limits, cos delta x minus 1 over delta x is equals to 0, while sine delta x divided by x, by delta x is equals to 1. So therefore we go back to this. Since this one, we substitute this one, the whole of this is equals to 0, and this is also equals to 1. So what we have left is cos x times 0 minus sine x times 1. So our dy dx is equals to 0 sine x, which means that dy dx is equals to minus sine x. If you find this video useful, please follow me by click the subscribe button, like and subscribe, so that anytime I upload another video, you will be the first to get notified. Thank you.